Hi everybody, sorry about the clickbait title, but I wanted to increase my page views. Today we're going to talk about the polarization of light. And you guys have heard this term polarization before. You heard it in the context of charge though. Remember, if we had an uncharged object, like a neutral object, that meant an equal number of positive and negative charges, then we could make that object polarized by, let's say, bringing a charged object nearby. Let's say this is an overall positive charge, and then these charges here, these positives and negatives in this one, are going to shift around until you have a pattern kind of like this, where the positive charges are now further away from the positively charged object and the negative charges have been attracted closer by. That's not really what's going on with the polarization of light. The polarization of light is a consequence of the fact that light is an electromagnetic wave, which we mentioned earlier. If you have a beam of light, like remember those ideas of light coming in these streams, like from drawing the sun? If you have a beam of light, it's made up of a whole lot of electromagnetic waves, all kind of bundled on top of each other. And remember, each of those electromagnetic waves is made up of these crossed electric and magnetic fields. And we call the direction of the electric field the so-called polarization direction, and that's just a definition. It doesn't really have that much to do with polarization of charge, but I guess you can think about it in that if you put an electric field around a charged object, the charged object will polarize. So it's kind of similar. But really what you want to think about is a beam of light is made up of a whole lot of these electromagnetic waves, and they're all kind of at different angles. So most light does not really have a definite polarization angle. It's what we call unpolarized. So in this drawing, you guys see two different examples of what's called an unpolarized beam. So here are all my E fields pointing in all kinds of directions. That's an unpolarized beam of light, and that would be more or less most light you see. So light coming from the ceiling, light coming from the sun, light coming through the atmosphere, that tends to be unpolarized. But under certain circumstances, when light reflects off a certain object or goes through a filter of some kind, what you can do is sort of cancel out all of these other beams that don't point in the polarization direction you want. So you cancel out basically all the ones I'm highlighting in green, and you end up with what we call a polarized beam of light. So this is a polarized beam of light. A good question would be, well, how do you do that? You do that with what's called a polarizing filter. And a polarizing filter, in this kind of mechanical analogy, you can think of it as like a grate with some holes in it. So you can see in this top drawing, what you have is this box with a slit down the middle, and it allows light that's polarized so that the electric field goes up and down parallel to the slit. That light can pass through, but if you had a beam of light that was polarized at a different angle, let's say one that was polarized like this would not be able to get through. So that's what you see down here, where you don't have the light getting through. So that's what a polarizing filter is. It only allows light that's oriented in the correct direction through. So if you have an unpolarized incident beam and you send it through a polarizing filter, you only get some of the light out. So you went from all of these different beams of light to just this one, where this one is oriented on the so-called transmission axis of your polarizing filter. You see polarizing filters a lot for cameras. You see them often for sunglasses. I have a little GIF for you of a polarizing filter right now. So in this GIF that you guys see going on right now, their black circle is the polarizing filter, and what the guy is doing is he's turning it so that the transmission axis changes. So there's some polarized light coming from the other direction. So let's say the light is polarized in this direction, and when the polarizing filter's transmission axis lines up with it, it's clear like it is right now, and when the polarizing axis is exactly 90 degrees away from where the polarization of the light is, then it's dark like right now. So we can figure out, based on where this guy's hand is, sort of where the transmission axis is of this polarizing filter. The worksheet you guys are going to do right now, I think is pretty straightforward. I don't think you're going to have any problems It's 100% conceptual. So have fun, and have a really good spring break, everybody.